history of materials. We're going to discuss how our use of those four types of materials, the metals, glass and ceramics, polymers, and composites, and how our use of them has changed over time. So which of those four categories of materials do you think have been used by people the longest? And why do you think that category was used the longest, and what was it used for? Here's a graph illustrating the four different types of materials. We have metals up here, we have polymers, elastomers here, and we have our composites, and we have ceramics. Now, you'll notice in the very beginning, at about 10,000 BC, we primarily used polymers and ceramics. But think about it, what falls into those categories? That's wood, skins of animals, that's stone, flint, pottery. That kind of makes sense because back then, those were like things that you could find around you. They hardly used metals. Metals actually is a process to get them out of the ground. You'll notice that we used gold, copper, and bronze as our earliest metals. And the reason is because gold and copper can occur naturally in nature and you don't need to do anything to it to get it out. So like once we start getting into our iron, you actually have to heat and smelt rock in order to get that out. So that required a whole nother process. But in the beginning, you could find a chunk of gold, and that would be the metal that they would then use. And a lot of times that was for decorative uses because gold is such a soft metal, it doesn't have much purpose alone unless it's used for jewelry or something. And so when we started getting into composites, this is when people started realizing that you can take mud and put straw in it and actually make a pretty decent hut to live in. So that's kind of when this started coming into play. Now, what you'll notice is as time goes on, as we move closer to the 1900s, you notice there's this huge influx of our use of metals. And our use of composites practically disappeared. And my question is, what the heck happened in this area of time? What was going on in the US in around the 1950s, 1960s? What do you think was taking place at that time? Now, as we are getting closer to present day, 2020, you'll notice we start evening out the use of all four types of materials. And we're now kind of equal parts of all four. Question is, where do you think we're going? Do you think it's going to kind of stay with these same scenarios? Do you think we're going to end up using less and less metals and we'll start using more composites? Just things to kind of think about because society in general and what's going on in the world around us is kind of determining what type of materials we need for our products. So we had our Stone Age, we had the Bronze Age, we had the Iron Age. So if we go back and look, here we have our Stone Age up in here. We have our Bronze Age. That's when bronze is being first introduced. And that was our first alloy we ever made. And an alloy is two different metals blended together where you can't see each one individually. And then we end up in our Iron Age. Well, that kind of makes sense because look, we have our cast iron, our steels, which contain a lot of iron, are making a comeback. And so now as we're moving in this direction, what do you think we would call today's day and age? So I kind of want to clarify this term stuff because that's really what material science is all about. We study stuff. And when we study our stuff, we're looking at metals, ceramics, polymers, and composites. And metals, these are going to be our elements that usually have a shiny surface They're good conductors of heat and electricity, can be melted down, fused, or hammered. We have our ceramics, which are materials that are made from non-metallic material like clay, hardened by firing at a high temperature. We can also take our silica, our sand, and heat it high temperatures. And when it cools as a transparent, fragile material. We have our polymers. These are the materials that are formed by joining thousands of smaller molecules called monomers, which we'll talk more in detail about in the spring when we start getting into polymers. Polymers are either natural or man-made, which obviously it has to be one of the two. But a lot of our natural polymers are things like our cotton, our trees. But with today's science in the world of chemistry, we're now able to make polymers that are very synthetic and that actually have completely different properties than what the natural occurring polymers have. And then we have our composites, which are man-made, and they sometimes do contain naturally occurring materials. And they're a combination of two or more materials that are attached together in such a way that you can still see all the parts and pieces that make them up because they're not fully blended. So if I was looking at a piece of cardboard, I can see that I have an outer layer, two outer layers of paper, and then that woven in the middle, and you can see that there's glue, you can peel it apart. Now, as we move through and science is changing and getting better, we're starting to blur the lines between these four. So typically when we would think of polymers, we're thinking of things that are of lower melt point. So if I were to take a piece of Tupperware and put it in the oven, it's going to melt. However, as science has improved, we now have these silicone trays that are a polymer, but we can actually bake in. And so we're seeing a change and a blur in our line in regards to the cutoff between what makes a polymer and what makes a ceramic. So things like this are occurring as technology is improving. So here's the thing that industry struggles with the most is if you make a product, I don't care what you are making, you can only have two of the three following things. You can either make it cheaper, you can make it better, or you can make it faster. So in other words, you can make it more cost effective, or you can make it a better product, or you can make a lot more of them in a short amount of time. You can't have all three. Something has to sacrifice. So if I want to make something really cheap, it's not going to be the best on the market, but I might be able to produce it really fast. If I want to produce something really fast and I want to make it really good, it's not going to be a cheap product. So this is the nemesis of manufacturing is they can't have all three. Something has to be sacrificed to get the other two. So what material science is all about is we're looking at the composition, we're looking at the structure, we're looking at the performance and the processing of materials. So we want to know what all goes into it, how is it structurally put together, how does it actually perform, and then how do we actually make it? So we're looking at developing a greater appreciation for the importance of the variety of materials in our lives. We're going to be studying how materials can be changed or manipulated, and we're going to search for new materials. Material science is ever changing. We have new materials being developed all the time, and their properties are so unique and interesting that it's hard to explain. So we'll be doing some reading, we'll do some articles, and as I find things and I can order them, I will bring them into the classroom so you can see some of these. They're really fascinating. So that's kind of the basics of the evolution, shall I say, of materials. So hopefully we learned a little something, and we'll only build on that from here.